All right, so this video segment is about battery charging. Okay, I don't know if you can see the GIF, if it'll play in the video recording. I'm not sure how that'll work. I think it might work. But anyways, down here in the right-hand corner, there's a little GIF of a battery blowing up. I believe this was on purpose, that someone blew it up on purpose to see what would happen. You know, everyone's curious, how does this going to blow up? But battery charging is a topic that's got a lot of safety tips in it, basically. A lot of things to be aware of when you're charging batteries to keep the battery charging safe and to allow it to, you know, charge your battery like it's supposed to. Okay, let me flip this over. So when we look at a battery charger, I have one here that happens to be just like the one on the screen. I'll show you guys here in just a second. We see an example here of a dual port battery charger. So we see channel 1 and channel 2 here on the screen, and we see basically a small set of pins here, a large connector, another one, and another one over here. And so battery chargers come in different shapes and sizes, but the best battery chargers are typically the smart chargers, we'll call them that. Okay, so let's turn on our video here for a second. Actually turn that one off. There we go. Okay, back to the main desk here. So here's my battery charger. You can see I've got all these cables and stuff hanging out of it, where it looks kind of maybe intimidating, but don't worry, it's not bad. Here's my wall plug. Okay, got the charger itself. We have some different ports on it here, the USB on the side that this one happens to have. Those are not on all chargers. And then we have the front assembly here. Okay, so we have these extensions and these are extensions, right? I can pull these out. The charger doesn't come with those. Those are just nice for ease of use, as well as for not wearing out the connectors that are built into the charger that are harder to replace. Okay, we have a little screen here, right? And we have a button and a scroll wheel here. All right, I'm going to switch over to the dot cam now so we can see some more things in detail. But this charger is about, you know, hold it in your hands. It's not huge, and it's not tiny either, I guess. All right. Okay, so here is the charger more in detail, I guess. Take this plug out for a second. I'm going to tip it up like this so we can see the end here. Okay, so hopefully you can kind of see that. The contrast isn't great. Maybe that's a little better, I don't know. Basically, we have our channel 1. Okay? We have our, let's see, what does that actually say? 654321. And then we have our out 654321 on channel 2. And we have a positive, negative, and then we have a negative here at the end and a negative here at the end. So if I were to charge a battery, say like this blue one we had earlier, right? I have my two plugs, okay? I'm going to plug one of them into the main port here. I'll take the other one and plug it into this section of pins here. Now it's important to plug this in the right way. Most battery chargers have it kind of limited, so you can't really plug it in backwards, but there are the little notches or nubs on the top of the plug here, okay? And you plug those in so they line up with the negative on one side. So the nubs face up. In this case, you can see that opening is wider on the top, okay, to accommodate those. And then we have the negative on that side. So I can't really plug this in backwards because the nubs wouldn't be on the top this way. I can't plug it in this way. I guess I could plug it in this way, but we don't want to. We want to move it to the right always because that negative wire should be on this side if the nubs are facing up, okay? So I'll plug it in like that. All right, so that's how we plug the battery in. Now the question is, why do you have to do that? Why can't you just plug in one of these, or why do we have two of these in the first place, right? So let's zoom out a little bit here. Plug this back in. I'll plug it into the wall here so we can see it power up and everything. We talked earlier and showed you the diagram of the wiring for the batteries, right? And we have these wires, there's one for each cell basically. And that's really important because lithium polymer batteries, and really any battery has multiple cells, I believe, want to be balanced, what's called balanced. So what happens is if you take your, let's go back to our diagram here. If you take your battery here and you have your cells, right, and you bring the battery, let's say you're charging it up and then you go fly. When you go fly, the battery will basically be pulling from all the cells at the same time. But sometimes cells have different resistances between them and things like that. And maybe one cell gets down to 3.7, the other one's at 3.8, and this one's at 3.5 or something. Okay, that's kind of out of balance, right? That's not that great. That battery might need some help. But the idea is we can fly like that. And then once we get back to charging our batteries, we want to balance out the cells again. So we start with the cells all the same. Because if we start with them out of whack, they're going to be even more out of whack if we fly with them like that. And if we get them too far out of whack, one cell could dip below 3.0 while the other cells are still up in the safe zone, and that cell basically gets destroyed. Okay, so with our battery charger, right, what the leads allow it to do here, okay, so we have our main lead that can put a lot of power through and into the battery, the main lead there, and then we have our balance lead. And so what happens on typical charge is the charger will put a lot of power through the main lead, kind of for the bulk of the charge. And at the end of the charge, it'll start to back off on the power it's putting through this lead and just kind of trickle charge through these leads in order to balance the cells. Okay, so you might have, let's move this back over here to an empty spot here. Okay, so let's say we have our battery and it's charging up. We started at 3.4, 3.5, and 3.38. Okay, there's our battery cells to start out with. We start charging, moving them all up, right? Okay, and as they charge, they get to a point where they're pretty close, but one's 4.1, 4.0, 4.15. Okay, so if we keep charging at the same rate, then this one's probably going to hit 4.2 fully charged before this one or this one will. Maybe these two will hit at the same time, and this one will be late. All right, so we can't just keep dumping power in there because then these ones will overcharge to get this one to 4.2. Okay, if they overcharge, then there's risk of explosion and things like that, light it on fire. Okay, so what I have to do when we get to this kind of ending spot in the battery, it differs between chargers, I'm sure, but somewhere close to the end of the charge of the battery backs off, charging through these main leads, and starts to trickle charge just a little bit to the individual cells that actually need to get up more, if that makes sense. So this one might, in this case, we might back off on the power going into these two cells and just put a little bit more power into this cell to get them all to, let's say, 4.1, 4.1, 4.1, and then you get all the way up to 4.2. This one's still at 4.18. This one's at 4.2. Okay, then we can essentially just charge this cell a little bit more and get them all up to 4.2 across the board, or at least as close as we can to that ideal. That's where we want the cells to be when we start to plug our battery in to fly something. That way they all come down more or less together as we're discharging the battery while we're flying. Okay, so back to the charger here. On this charger, we have a couple pretty relatively simple menus. This battery is plugged into channel 2, so I'm going to be dealing with this side of the screen. This is for the other port here. So I'm going to go ahead and select that side. Okay, so now it's large. I'm going to click on the scroll wheel, and it's going to give me some options here. It says, what do you want to do? Do you want to charge? Do you want to discharge? Do you want to put your battery into storage voltage? Do you want to just balance the battery? What do you want to do? So I'll just say charge for this example. Okay. Battery type is LiPo, so this is a lithium polymer battery, or LiPo. Cell voltage at the end of this charge should be 4.2 volts. Okay. And then we have the cell count. It's already kind of picked that for me because it can tell how many cells. But you could try to adjust that if you needed to. I don't know why you'd need to, but you want to make sure it's correct for the battery you're using, which is a 3-cell. And then our current setting. So we haven't quite talked about this yet. When you're charging a battery, the safest way to do so, safest combination, fastest to do on pretty much any lithium polymer battery is to charge the battery at 1C. So if you remember from our other video when we calculated the C rating, right? This battery is a 1400 milliamp hours, okay? So to get the 1C rating for 1400 milliamp hours, we just divide by 1000, okay, equals 1.4 amps is 1C, okay? So if I'm going to charge this, oops, sorry, off screen. If I'm going to charge this battery safely and as quick as I can, I'm going to charge it at 1C. So I'll go ahead and select that, and we'll go down to 1.4 amps. Select that, and then we go ahead and start task, and we say start. Okay, it's going to start charging the battery, and let's see if we can get a little bit closer so you guys can see some of these details on the screen here. It's always hard to focus on screens too because they get washed out. There we go. Okay, so we see right now this battery's actually got not a full charge but close. 4.1 on the first cell, 4.1 on the second cell, 4.1 on the third cell. So we have up to 6 cells this battery can charge. Okay, and if we look up here, we can see the amps. It's putting 1.4 amps into the battery. This is the total battery voltage right now, elapsed time, and the milliamp hours it has put into the battery. Okay, if I scroll over with my scroll wheel, this actually will give us the resistance of each cell internally on this charger as well, which is really nice. As resistance gets too high, the battery will be time to retire the battery so it doesn't get damaged or have a problem. But this cell resistance looks okay. A little bit interesting that these ones have higher resistance than this one does in the middle there. But if you keep an eye on those resistance levels over time, you kind of get a sense of when it's time to retire the battery. All right, so once the battery's finished, it'll beep at me and tell me the battery's done. Okay, but that's essentially how this works. If I want to stop the battery, I can just stop it right here. Okay, now it's stopped. And it just gives me the current cell voltage here, as well as the total cell voltage, or total battery voltage there. All right. Okay. Let us go back to the PowerPoint real quick here. All right, so battery charging is really important. Here's another, I don't know if you'll be able to see this GIF again. I'm not sure how that works with the recording, but anyways, the guy leaves his battery unattended charging. Not a good idea. Don't charge your batteries unattended in your basement when you're not home. Things like that. They can light on fire. They can explode, and if that goes up, then your house might go up too if you're not home. So please don't do that. Also, make sure you charge your batteries in some kind of container that's safe to hold them. There are lots of fire-resistant bags on Amazon that are meant for charging batteries in. At a minimum, I'd use one of those. Even better to use some kind of metal container if you're at home, especially. The ammo cans you can find at Harbor Freight work pretty well, the metal ones. Just remember, if you use an ammo can, take out the seal around the lid of the ammo can so it doesn't become a pressurized bomb if a battery blows up inside of it. Okay, we want to keep the fire contained. We don't want to keep the pressure contained because that would be bad. All right, here is a chart here from our textbook. Our author gives us this chart and just shows us different numbers of cells in series, fully charged voltage, nominal voltage, safe discharge voltage, and return to home fail-safe voltage. So you can take a look at that in the slide, but basically he's giving you some recommendations for, hey, if you're going to set this up on your drone to return to home after a certain time, then maybe this is a good voltage to do that at. If you're going to basically use your battery and fly it down till a certain voltage, then that's the voltage he would have you use. You can use your own settings on those as well if you want, but these are some of his recommendations. Okay, we'll pause the video there and break for this section.